Shishi, thank you very much. Ni hao, my name is Dan Kahn. I am the Executive Director of the Cloud Native Computing Foundation, and I'm thrilled to be here in Hangzhou at the Alibaba Cloud Conference. I just flew in yesterday from New York City in order to be here, and so I'm very excited. I would like to walk you through a little bit about the Cloud Native Computing Foundation, what we're doing with our projects like Kubernetes and Prometheus and Containerd, and then also take you through what I call a brief history of the cloud. But first, for my foundation, we are a little bit less than 2 years old. So it's very new, but we're part of the Linux Foundation, which is 17 years old now. And we now have 12 projects in the foundation. We started with Kubernetes, which was contributed by Google about a year and a half ago, and we've been adding a new project every month or two. And on the bottom row here, you can see the 20 companies that are our platinum members and the main backers. We're also thrilled to have a very significant support from Alibaba. They're a gold member and have been instrumental in us moving forward, especially in China. So most people know the Linux Foundation for Linux. And we do employ Linus Torvalds and the stable kernel maintainer, Greg Kroll-Hartman. In fact, we brought both of them to China for the first time a few months ago in June. We had our first conference in Beijing that was very exciting. But what's interesting is that the Linux Foundation is now doing far more than just Linux. So you may be familiar with Let's Encrypt, which provides free TLS certificates to now a majority of the internet, cause it's the biggest certificate authority completely for free. In networking, we have a project called ONAP, which combines together technology from China Mobile, the OpenO project, with technology from AT&T called eComp, and is now providing a software-defined networking solution that's going to be used by more than half the mobile subscribers around the world. On the cloud, we have CNCF, and that's what my talk today is about. In automotive, every new Toyota Camry is now using Linux inside of its automotive system, and that's going to be going in many, many more cars over the next few years. Our previous speaker just mentioned Hyperledger on the blockchain, where Alibaba has been a leader, and we've been very happy to have their support. And then you're probably familiar with Node.js as one of the most exciting new application frameworks. So all of these technologies are part of the Linux Foundation. The Linux Foundation is now really a foundation of what velocity projects on the internet. So which projects have the most developers, are making the most changes, the largest community. And what makes it a strange chart is that it's a log chart. So down at the bottom, this is the number of commits on the x-axis, and on the y-axis is the number of pull requests and issues. And what you can see at the very top is the Linux kernel remains the highest velocity project in the history of open source. And interestingly, Chromium, that's the open source version of Chrome, is very close to it. But I want to point out in green here, Kubernetes is, depending on how you count, the third or fourth highest velocity project. In pink, right in the middle, because my colleagues, Patrick, going to be speaking from Docker right after me. And so this has been a neat project, and you can see on the URL there the information, but all of this is based on, it's all open source if you wanted to learn more about it. But what you can are communities, fastest moving communities in the history of open source. Okay, and now I have one more chart that is very difficult to read, but let me just emphasize the URL right here, .com/cncf/landscape. You can get a high resolution of the version of this. But this is trying to give a view of, and what it's saying is that there are over open source projects. Thank you very much. Sorry about that. There are over 300 different open source projects and companies that are providing these technologies. So at the bottom, you can see Alibaba Cloud is one of the 5 biggest cloud companies in the world. And across the different areas, what we find is as enterprises roll out cloud-native technologies, they often need to pick one project or one vendor to work with in each of these boxes. And so what this diagram is trying to do is to build a map and say, here are all of the options, and then the ones in dark blue are CNCF projects. So we're not saying that we're the only one to choose, but we're saying that our projects are sure to work well together. They're all open source, but they're backed by a number of different companies. They're a very safe, reliable path to the cloud-native future. Okay, so now let me give you what I call a brief history of the cloud. And the idea here is this is very opinionated. This is my particular history. But it is trying to go through the progression over time. So we start back in 2000 with Sun Microsystems. And at this moment, in 2000, I was a venture capitalist in Silicon Valley, and companies would come to me and say, I have the idea for a website that I want to build. It wasn't apps yet. And they would say, I need $2 million or $3 million in order to buy enough hardware, so if my website is successful, I can meet the demand. And essentially, they would go spend almost all of that money with Sun. And so Sun's was very, very successful. But the key thought is that the application building block, when an entrepreneur or an engineer was thinking about an application, was a physical server. But the secret of this is that a ton of those applications were not using all the capacity of the server. In fact, there's a lot of calculations saying that many applications were only using 3% or 5% of the server's capability. So now we jump to 2001 with a VMware. And in each of these cases, this was not necessarily the company that invented virtualization, but it was the company that popularized it and really profited the most from it. And VMware built a software solution to wrap your application, and now you could put many different applications all on the same server. They would think that they each had their own server. And so the application building block that the engineer would focus on was no longer the server or a rack of servers, it was VMs. And as a result, VMware made billions and billions of dollars and was incredibly successful. And arguably, virtualization was the most important computing technology of the previous decade. So now we fast forward to 2006, when Amazon Web Services popularized the concept of infrastructure as a service, or IaaS. And this was this magical moment where they took what had previously been CapEx, the entrepreneur needing a couple $1 million in order to build out the infrastructure, and changed it to be OpEx, an operating expense where they could bill by the hour for those servers. And more recently, they changed it to billing by the minute. And in fact, this month, they now offer per second billing. It doesn't make that much difference, but it's just an amazing thing that you now just spend for the capacity that you're actually using. The application building block they called an Amazon Machine Image, an AMI, but it was still basically the same thing as a virtual machine. The building block from the engineer's perspective didn't really change any. And now we fast forward to 2009, and you had this company, Heroku, that was extremely successful in Silicon Valley. And for a lot of people, like myself, really introduced us to the idea of DevOps. And so you're an engineer, you're working on an application, someone comes over and says, oh, there's a bug here, when I click this, it doesn't work right. Maybe it only takes you 1 or 2 lines of code in order to fix it. You get it working on your own developer machine, and then you type this magic phrase, git push Heroku, and about 30 seconds later, the new version of your application is live on the website. And so to see that kind of progress and be able to get to the position of making dozens of deployments per day instead of what many companies had is a new version once a quarter or a new version maybe once a month, it just totally changed what we call the development velocity around software. And so the building block that they had, they called a build pack. It basically was a container. It's an opaque container, meaning you can't really know what's going on inside. There's a lot of sort of magic that is hiding from you. But if you were using one of their approved languages, Ruby on Rails or Node.js, and they added others over time, it really gave you just an amazing experience. But the thing that I want to emphasize on those first 4 steps in the history is that all of those were closed source proprietary companies. They all made a lot of money, but now the next 4 steps along our journey are all open source. And so in 2010, you had OpenStack form, originally by Rackspace and NASA. And in a lot of ways, you can see OpenStack as being designed to compete with Amazon Web Services, providing IaaS, and with VMware, providing a good way to run VMs. And it took longer than they thought it would in order to really have the software running reliably, but it works very well today. There's deployments all around the world. There's a lot of people that are very happy with it. And it was successful at bringing together a whole group of vendors to offer a competitor an open source competitor to those products. Then in 2011, Cloud Foundry was launched, and this was really an open source alternative to Heroku. So Heroku invented and popularized the concept of a 12-factor application, and you can think of this as a set of guidelines, a set of rules or guardrails that if you follow them, it makes it very easy to build your application, to deploy it, and to scale it out in order to meet demand. And so it's things like parity, having your development and your production environment be the same, defining all of the state in environment variables, treating logs as a stream instead of a file. And Cloud Foundry took all of those ideas from Heroku, but said, no, you don't have to just run them on Heroku's proprietary system. Here's an open source implementation that you can run on your own hardware or on a public cloud like Alibaba or anywhere else. And again, it took a little bit longer, I think, for that to get fully mature. It launched in 2011 and became open source in 2014. But there's now a number of different companies that are very happy with Cloud Foundry. This is also another foundation within the Linux Foundation. Okay, and now I'll come to 2013, which is probably the biggest surprise in the story. It was this company, Docker. And what's interesting about Docker is they took 3 technologies, this guy Solomon Hykes, that were already available. LXC had been added to the kernel and by Google, Union File Systems by some academics, C groups had been added several years before. And I draw the analogy to the World Wide Web in 1990 with Tim Berners-Lee. When you go back and you look at, well, what was the web? What was special about it? There's really 3 parts. He took HTTP, which is just a slightly better version than FTP, and he took HTML, which is just a simplified version of an already existing markup language called SGML. And then he invented this concept of URLs, but there's nothing that special about it. It's just an address, a standard way of writing addresses that you can access any resource. But sometimes when you take pre-existing technologies and combine them together with a really easy-to-use interface, magic happens. And I think that was the case with the World Wide Web. And I think it really the same thing with Docker, where these three technologies allowed you to wrap an application in a way that it became immutable, repeatable. And so Docker solved this age-old question of you're a software development team, you have a new member get hired, and she sits down at her computer the first day, and she's given a long list of instructions of how to set up her computer in order to have the development environment running, in order to be able to start coding. And she goes through 4 or 5 hours of following commands and installing software and doing the steps, and then she comes to an error, and she goes to one of the existing people, sometimes somebody with a beard, and says, I got this error, and here's back, oh, well, it works for me. I don't know what your problem is. And so the magic of Docker is that in development, when you have a working container, a working installation and system, you can exactly copy that and give it to everybody else on the team, even if they're using Mac or Windows or Linux, and they can be guaranteed to have exactly the same environment that you totally avoid that works for me problem. And finally, that brings us to CNCF and to Kubernetes. And so the idea here is that we describe cloud native as having 3 main components. That you divide your application up into lots of different pieces that are called microservices. You wrap every one of those microservices in its own Docker container, and then you use an orchestration platform like Kubernetes in order to have all of those pieces work together. So let's now review that kind of quick history. And just look at what were the trends over that time. So we started out with Sun, where the application building block was a piece of physical hardware. And then it moved to a virtual machine, and then to build packs, which are kind of opaque container, and then to containers, like Docker containers. And so during that time, the spin-up time, it's gone from heavyweight to lighter weight. The spin-up time has gone from weeks, which is what it took to order a new server and have it delivered and installed, to seconds for virtual machines, to 100 milliseconds or less for a lot of container environments. And then there's this concept of going from pets to cattle, where it used to be that every server was custom configured and you never quite knew what state it was. Instead, with cattle, you treat all the servers as the same and process them in bulk. And then finally, the provider went from a single company, closed source proprietary, to being able to have multiple companies, open source, that you can choose between them. So the one other detail that I'll just give in that is people say, well, what about PaaS? PaaS, this 12-factor platform as a service, was really popular. Does that mean it's going away? And the answer is no. There's still a ton of value to 12-factor. It's a very good pattern for developing some of or even many of your applications. But 12-factor is like a set of guardrails that it's nice to be able to start there. Sometimes your application outgrows that, and you need to come up with, you need to be able to store state, you need to be able to provide other things. And so our message is that we think you should be building PaaS on top of Kubernetes and similar orchestrators, not as a alternative to it. Okay, so let's now go through and say, why are people excited about cloud native? What are the benefits that this evolution has actually brought? And so the first one is the ability to avoid lock-in. That with open source, if you want to work with a company like Alibaba, they're very happy to support you. They can provide technical support and do that. But if you want to, you can also download the software yourself from the internet, see exactly how it works. If you find bugs, you can improve them. You're not locked into a single vendor. The next one is scalability. So there's a statistic from Google that they start up 2 billion containers per week. That's 3,300 per second on average, but in fact, at peak times, their number is far, far higher than that. And so the idea is that these containerization, these orchestration systems are designed to scale to really any imaginable level that you can have an Alipay kind of application that you can support with it. The next one is agility. And so this is my slide for microservices. And I'll give a little shout out to these pirates who had to work unbelievably hard to get the containers into these boats. But the idea is that you separate out your application into different pieces. You explicitly define how each of the different microservices work with each other, how they rely on each other, and all of that is implemented in software, in code, that you can version control and evolve over time. The next piece is orchestration. And so the idea of having a central orchestration layer that can keep track of all of these dependencies, can automatically scale to meet demand, and of course has high availability itself, so that if any given server or piece dies, the orchestration continues working normally. And then the next one is resiliency, which is that individual containers are going to fail, servers, even entire data centers, and that you can design and build a system that can automatically deal with that, that also can deal with the resiliency of demand, that when you have a flash sale, a large number of new users, that you can automatically scale up to deal with that. That is the kind of basic idea of CNCF and cloud native, and why we're excited about this space, why we think there's a ton of opportunity. We are going to be holding our biggest event of the year in Austin, Texas on December 6th through 8th. And would love, we're actually going to be having a lot of attendees and a number of speakers from China. We would love for you to consider attending. We think it's really a fantastic opportunity to learn more about this space. And then in May 2nd through 4th, we're going to be in Copenhagen, Denmark, and holding that event again, and which should be just as large, and a number of other exciting opportunities. So we would love to have many of you consider attending. And finally, I will just include my email, and also this presentation is available at this URL. That if you have questions or you want to share it, it may take me another day, but I'll be uploading the Chinese version of it as well. And I would encourage you to please reach out to me with any questions. CNCF is dramatically expanding our membership in China. We have local representatives here in Hong Kong, and we're very eager to work with partners in China, especially end users and providers like Alibaba. So let me end there. I'm happy to take a minute and answer some questions. Let me just put my my earpiece in so I can understand them. But thank you all very much.